morning. This is Ben Gallagher coming to you live from Berry Potassium. And today we're going to explore the physics of a balanced soda can. Alright, so here in this video we have an empty soda can. An empty soda can that will soon be filled up with an unknown amount of water. And a full soda can. So I'm going to fill up this can with water. And I'm going to balance it. Alright, so now I want you to pause the video, and I want you to take a guess at how many milliliters of water it takes for this soda can to balance. Keep in mind, one can is 355 milliliters of water. Alright, so the reason this soda can stands up is all about torque. This diagram here can explain why. So right here, right where the soda can meets the table, is the pivot point for the soda can. And with this unknown liquid, it allows the soda can to have an equal amount of mass on each side of the pivot. Therefore, this dot represents the center of mass. And the center of mass is directly above the pivot point. Therefore, there's an exact same amount of torque applying right here on this side of the soda can as there is on this side of the soda can. Due to gravity, 50% of the torque is coming down clockwise on the pivot, coming down this side, and 50% of the torque is coming down counterclockwise on this side of the pivot. Therefore, they balance each other out, causing it to stand on the pivot. So there's a reason that this trick only works when there's a certain amount of liquid in the can, and I'll explain why. So when you try this trick with the empty soda can, it falls over. This is because above the pivot point, there's more mass to the left than there is to the right. This is because, obviously, there's more of the soda can to the left than there is to the right, and with nothing inside, the soda can is the only thing with mass. Therefore, with more mass to the left of the pivot than to the right, gravity causes the soda can to pivot to the left. The same goes for the soda can that is full. There's more mass to the left of the pivot than there is to the right, causing it to fall over to the left of the pivot. To further explain, the same principle of the soda can applies when I balance this here nail file on my finger. At this point, the pivot is directly above the finger. And since it's balanced, there's an equal amount of mass on each side of the pivot. Therefore, an equal amount of torque is being applied this way as it is this way. Therefore, they cancel each other out and it balances. However, when I add just a little bit of mass, like this here chocolate, on one side of the nail file, it falls over. This is because when I put more mass to one side of the nail file than to the other, it causes the file to turn that way because more torque is applied to that side. Okay, so to relate this back to the soda can, when the nail file was equal on both sides, that is like this. There's an equal amount of mass on each side of the pivot, therefore it's balanced. However, when I put the chocolate on the nail file, that was like both of these situations, where there's more mass to one side of the pivot than there is to the other, causing it to fall. Man, all this videotaping is really making me thirsty. I could use 100 milliliters of water to quench that thirst.